So this is the motion of an object projected horizontally from a height. So if you look at it, two independent motions are combined here. We have the motion under free fall, which is a vertical motion. Then the second one is the horizontal motion. Now let us look at the time it will take. Now experiment shows that what the time it will take for this object to move along this parabolic path it equals the time it will take as if this object was falling freely under the influence of gravity, and also equals the time it will take to cover this range. This is the range from this point of projection. This is the final landing point of the object. So this is the base of the tower, assuming this is a tower or cliff. Then the object projected here. So in this type of projection, we call it what? Horizontal projection from a height. Now, the object is not falling freely here because it is projected with an initial velocity. Now, the object keeps going, moving along this parabolic path. And as it gets to this point, the velocity remains constant, which is this velocity. Now, our normal equation now, since the body, we consider the first motion where the object is falling under gravity. That is a free fall. The acceleration becomes equal to g. That is your positive g. Now we are having equations of motion. The first equation we know is that v will now give us equal to, that is v of y, equal to uy plus gt. So then number two equation, where we have v squared, that is vy squared now equal to what? Uy squared plus 2g, because this one becomes a h. That is the height. Okay. Then the next one is where we have, okay, h now, s. Remember, we normally use s equal to ut plus half at squared in our linear motion. Since this one is now dealing with vertical motion, considering the height of the tower or the building. So we now give us equal to uy squared. That is what the vertical velocity of what this, of this motion, plus 2gh. Okay. Now, remember, since the object is dropping or falling from a height, projected from a height, so your velocity, vertical velocity, initial vertical velocity becomes what? 0. Now, if you place 0 into these equations, so the first one, your vy becomes 0 plus gt, which is equal to what? Gt. This becomes your equation 1. Okay. Now let's look at this one here. We have a vy squared now. Your initial velocity is 0. We have 0 plus 2gh. So your v squared y, that is the vertical velocity component, equal to what? 2gh. So this is your equation 2. Now also here, we have the other equation. Remember, this one is not replacing our g. So in that case, since this one is also 0, remember we have a s, it becomes h now, okay? Sorry, I just lost audio. So we have h is equal to the vertical velocity, that is initial velocity uy t plus half gt squared. Now we have u of y, the vertical velocity is 0. So we'll place 0 there. Then plus half gt squared. Then we have h, which now become hy equal to, remember that is vertical distance, equal to half gt squared. So this becomes our equation 3. And remember, this equation here is what we normally use to determine the time of flight for this horizontal projection. So from here, if you make t the subject of the formula from that equation 3, it becomes the time of flight. Then that equation 1, the t that we have there is the time it takes to reach the maximum height. So that is where we have the v of y is equal to gt. So now, at this base, when the body lands, so we have just the horizontal velocity, which is ux. So to cover this range from this point down to the landing point, we will say r equal to what? This horizontal velocity multiplying the time of flight. That is the time it takes to move from the point of projection down to the landing point. So here, we want to determine the range from this now. Okay, so which means our range is equal to x, that's u, t. Remember, this u here now is now the horizontal velocity of projection. So that is where we will have this t at the time of flight. So if you come to this point here, if you make t subject of formula, you are going to have that. So calculate the time of flight there and multiply it by the range, which is the velocity, the initial velocity of this projection. So to give us the range. So that is all about that. Let me show you how it became r equal to the initial velocity multiplied the time of flight. And remember that range now becomes ux times, well, that is what a horizontal distance, ux times t plus half gt square. And at this point, when the object lands, the acceleration becomes 0. So in that case, remember we said our acceleration is equal to our g, acceleration due to gravity. So the whole of this place becomes 0. So if we put 0 there, it means at the end of the day, we are going to be left with just the initial velocity multiplying the time of flight. So that is why we call this horizontal distance, which is the range, is equal to uxt. So that is the formula for calculating the range. I hope this video is very helpful to somebody out there. I want you to help us to share this post and do well to like and comment and follow this page for more updates on physics. So please subscribe to my YouTube channel, Physics and Mathematics Lovers, on various topics in mathematics and physics. And also make sure that you keep engaging in my post. As you do so, God will bless you. And you that always share this my post, may God bless you. Amen. Bye.